Good evening. How are you guys doing? I hope you are enjoying the journey and doing fantastic. The festival season is arriving. Yes, fantastic. Superb, superb. Okay, so chalo, let's begin our journey today. Let's start with our ritual. Let's welcome the new people in the room first. Anybody first time attending the live session? Just let me know in the chat box. Just type me in the chat box and we will first welcome them and then we'll start our session today. Anybody in the room? Okay, Charlene is there. Who else? Who else? Yeah, generally on Mondays we have the new people. Saturday generally because they already have attended the Monday session. So, okay, fantastic. So everybody just type welcome. Yeah, okay, Shapia has joined after a long time. Fantastic. Everybody just type welcome Charlene in the chat box. So Shalini is getting the royal treatment today because the only one person joining new today. Okay, super. Chalo, welcome, welcome, welcome. And let us discuss about the stability of the process. There are 8 steps, 8 tests which we are going to learn today, which are very, very crucial. And then something about, all the practical applicability of it. Okay. And yeah, well, a new look, huh? Okay. So the practical applicability of the stability, the 8 test, as well as 95% confidence interval. Okay, so manually we will calculate the 95% confidence interval and practical application. I'll give you example of how practical application of 95% confidence interval actually can help us to take the decision. Okay, chalo. So let me quickly shift to my whiteboard. Okay, and very important aspect of statistical process control. SPC stands for statistical process control. Lean Six Sigma basically is, I always say this, it's a garland of lot of tools taken from, like from Edward Deming's PDCA cycle, from, Toyota production system, from TPM, okay, from design thinking, from statistical process control. So Lean Six Sigma is a combination of all these tools one by one. Okay, so it has taken lot of insightful, important tools from statistical process control. And who is father of statistical process control? The name of the person is Walter Shewhart. Walter Shewhart. Okay. Now, Walter Shewhart was a statistician who basically started how to monitor the process with the help of statistical tools, with the help of graphs, with the help of control charts. He is the person who mentions that any process which flows through plus and minus 3 standard deviation is a stable process. Let me give you example. If you plot, let's say, if you plot the production of one process, okay, it can be anything. You can plot the call time. Okay, the call time, the call, each and every call time can be put on the graph. Okay, let's say it can be production, it can be call time. So somebody is just plotting this graph on a graph. Imagine they are plotting this graph, on a simple graph paper. Next, what Walter Shewhart has done is he has taken the average of that. Okay. So whatever is the data, he has taken the average, and average is called as X bar. Okay. And what he says, any process which flows plus 3 and minus 3 standard deviation is a stable process. Stable meaning, there is no special cause in that process. There are all common causes. There is all common cause variation present in the process. Okay. Now, right now here, let me give you an example of this. Imagine X bar is equal to, let's say 40. Okay, X bar is equal to 40. And the standard deviation, if I calculate the standard deviation of this process, let's say standard deviation of this process is, let's say 4. Okay. Now, as per Walter Shewhart, any process between +3 and -3 standard deviation is called a stable process. And he has called that as UCL and LCL, upper control limit or lower control limit. Okay. So the formula for upper control limit is X bar plus 3 standard deviation, and formula for lower control limit, you can make a note of this, especially the new people. The formula is X bar minus 3 times standard deviation. Okay. Can you just calculate upper control and lower control limits for me? The numbers are given in front of you. X bar is given, standard deviation is given. So you just have to calculate it. X bar is 40 plus 3 standard deviation. X bar is 40 minus 3 standard deviation. Can you just type in the chat box quickly? Type in the chat box. So this X bar is equal to 40. Yeah, Vishalji, you can start your black belt course now. And congratulations for your green belt. Okay, so 40 is the X bar. So understand this. So on 3 standard deviation, try to understand this. So this is 1 standard deviation, which will be 44. Let's say second standard deviation, which will be 48. And the third standard deviation will be 52. Yes or no? So upper control limit is 52. Everybody got 52? Yes. And similar to this, 1 standard deviation from the mean is 40 minus 4, which is 36. Then second standard deviation from the mean is is 32, and the 3 standard deviation from the mean is nothing but 28. Everybody got this? So USL is 52 and LCL, sorry, not USL, UCL is 52 and LCL is 28. Are you clear? Everybody just type yes in the chat box. No, we have just assumed. We have just assumed. We have just assumed X bar and we have assumed standard deviation. That's it. Clear, everybody? There is no calculation involved. We have assumed that there is a process which the mean is 40 and the standard deviation is 4. Okay. In that case, what will be the upper control limit and the lower control limit? Clear? So the formula is X bar plus 3 standard deviation is the upper control limit, and X bar minus 3 standard deviation is the lower control limit. Okay. So anything which is in between these two band, which is upper control and lower control, is called common cause variation. This variation is called common cause variation. Whatever is in between these two lines. Okay. Now, if any process, if any data point goes beyond this point, let's say like this point is called special cause variation. You can just make a note of this. In between, it is called common cause variation. And if any process goes beyond this point, it's called special cause variation. Like, for example, I always give this example. Like for like your office arrival time. If I plot your office arrival time, there will be 5, 10, 15 minutes, there will be some fluctuation. But on one fine day, let's say your car breaks down and you come late by 1 hour. That is a special cause variation. That is the assignable cause variation. You can assign the cause to that. Are you understanding? So this is very, very important factor, that a common cause is within the control limit, and assignable cause or a special cause is beyond control limit. Are you clear with this? Just type yes in the chat box. It's called common cause variation and a special cause variation. Clear, everybody? Till now with me? Just give me yes in the chat box.
Sir, sorry to pitch in between. How it comes 52 UCL? I have put it on chat, but I'm
This is
not
the
getting the
formula,
answer.
na? This is the formula. X bar plus 3 standard deviation. X bar is 40 plus 3 into standard deviation is 4, right? So 3 into 4 is 12. So 40 plus 12 is equal to 52. Clear?
Okay, understood.
Yeah. Same goes the LCL, which is X bar minus 3 standard deviation, which is 40 minus 12 is equal to 28. Clear? Yes? Yes, very good. 40 plus 12 and 40 minus 12, right? So whatever process in between, it is called a stable process. Now, if the process is running in between these two, it is called a stable process. And this test, this control chart, it's called stability check. Write this down. Stability check. This is called stability. Why it is so important? Why it is so important? Because now any process, okay, which is a stable process becomes predictable process. Understand this? Any process which is a stable process becomes predictable process. Okay. Any process which is unstable in nature becomes unpredictable as well. It's like, for example, any what you can say, mischievous child. Okay, बहुत मस्ती करने वाला child होता है. That person, that child is unpredictable. वो कब क्या behave करे, we don't know. Similar to the process, unstable process can behave unpredictably, and that's where statisticians have the challenge, because we have in statistics, it's all about probability. Statistics is all about the inferential statistics, right? Because from the data we take some inference about the population. If the process is not stable, our prediction about the population can go haywire, can go wrong, and that is the risk we carry. So stability check becomes very, very important. Okay. Now, one question which comes is, why this plus and minus 3 only, why not 4, why not 5? Okay. So after a lot of permutation combination, Walter Shewhart, okay, has understood that at plus and minus 3 standard deviation, there is something called, have you heard about the senior people, especially the people who have completed their green belt and black belt both? Okay. Have you, in the hypothesis testing, okay, have you heard about alpha error and beta error? Just type yes in the chat box. In the hypothesis, we cover alpha error and beta error. Have you heard about it? Yes or no? Yes, alpha error or beta error. Yes. Now the new people, if you have not heard about it, don't worry. It is a part of green belt as well as the part of the black belt curriculum as well. Okay, alpha error and beta error. Okay, so alpha error and beta error are two errors basically, which are the sampling errors, which yes, exactly, innocent person jailed. Very nice, very nice. Okay, and the criminal person is released. Correct. So alpha is the innocent person is jailed, is an alpha error, and what is beta error? Beta error is a criminal is released. Okay, it is called a beta error. So in the judgment, there could be some sampling error, there could be some these kinds of error, alpha and beta. At plus and minus 3 standard deviation, alpha and beta error risk get nullified and balanced out. Okay, so at plus and minus 3 standard deviation, the process gets that equilibrium which balances out this alpha and beta error. Okay, That's the reason after a lot of permutation, combination, a lot of experimentation, Walter Shewhart finally has agreed that, okay, process between plus and minus 3 standard deviation is said to be a stable process. And then, the statistical fraternity, the community, the global community has given the, what you can say, go ahead with this. And since then, we are following this concept. Clear hai? So plus and minus 3 standard deviation process is said to be a stable process. Now, checking that, how do we check this? We check this with the control chart. Okay, we check this with control chart. Now I will do the basic control chart, and then we will do something which is very, very interesting. Okay, so let me just quickly share a file with you. Let me just quickly share a file with you guys. Okay. If you have Minitab with you, Minitab laptop with you, you can just open that and let me just share this file with you. First, we'll do a basic control chart. Okay, first we'll do a basic control chart. You can see here this, I'm just sharing a file. Okay, the name of the file is process capability. You can just download it. Yes. Just download this file which I have just shared in the chat. Just click on that, it will get downloaded. If you have laptop or desktop in front of you, it will open. Okay. If you have only mobile phone, you are traveling, then it will not be opening right now. Okay. Yeah. If you don't have right now, just observe what we are doing. You will understand it. Clear? Yeah. Once you have opened, let me know in the chat. ओपन होने के बाद मुझे बताइए चैट पे, ठीक है? डन? Super. Chalo, let's. So this is the file. Let me open as well. All right. So this is a chat. This is a file. So let's make a simple eye chart over here. Go to stat. Everybody just follow this. Go to stat, control chart. Variable chart for individual. And let's make IMR chart. Okay, IMR, individual moving range chart. We'll make IMR chart right now. Okay, individual moving range chart. Select that. Select in the variable, select chocolate weight. Double click on chocolate weight. And I don't think anything else needs to be done. Okay. Yeah, as of now, let's say okay. Yeah, everybody got this? I just repeat again, go to stat, go to control chart, variable control chart for individual, and select IMR chart. Okay, I stands for individual. Fantastic. Got it, everybody? Yeah. Now, just try to understand this. I stands for, this is called IMR chart, right? IMR. So there are two charts. One is called individual. And MR stands for moving range chart. Moving range chart. Now, what is I and what is MR? I is nothing but the individual data points are plotted. I for individual, okay? So the first one is 42, second one is 40.1 or whatever. So all the data points are plotted. Then the average is plotted, which is X bar. Upper control and lower control limits are plotted accordingly. Okay. Yes, and what is moving range? So individual is clear, right? Individual is all the data points are individually plotted. Are you clear, everybody? Individual clear hai? Individual graph. Just type yes in the chat box. Super. Okay. And what is moving range? This is called moving range chart. Okay. Just like Mahesh ji has mentioned, moving range is nothing but a difference between, understand this. Moving range is nothing but the difference between the consecutive data points. The difference between consecutive data points. Okay. Let me explain you that. For example, let me take you to the data once again. So first point is 42.1. Okay. So that will be plotted in the individual plot. The second point is 40.7. That will be plotted in the individual data point. Okay. What is the difference between these two? The difference is 1.3. So 1.3 will be plotted. Look at this. 1.3 will be plotted over here. Can you see? So the difference between the consecutive data points is plotted in the moving range. Are you clear with this? Just type yes in the chat box. So all these are differences between the consecutive data points. Clear hai? From UCL and LCL. So this one, right? ये MR chart का बात कर रहे हो ना लक्ष्मण जी आप? Right? It is not the same, correct? That's what you're asking? Yeah. So because see range will never have negative value, right? So range will never have negative value. Understand this? So range will always have the positive value. The difference between two values is going to be the positive value only. That is the only reason our lower control limit stops at 0. It is not going below 0. That is the reason lower control limit and upper control limit are not equally distant from each other. Clear? But the main objective of doing this is the data stable? In this case, you can observe here. You can observe at this point. Can you observe this is going beyond the control limit and there is one number attached to it. Okay. This point, and this point, all of them are going beyond and there is one number. That means the process is not stable. Are you clear with this? There are 3 data points which are going beyond control limits. Are you clear? Just type yes in the chat box. Clear hai? Any process which is going beyond control limit is not a stable process. Okay? Yes. Now, what happens is, along with this, software gives us some more, what you can say, some more advantageous, what you can say, thing. What is the advantageous thing? See, this is clearly evident, right? If it is going beyond control limit, it is clearly evident. But what if we get some signals before the process goes beyond control limit? Okay, so those signals are called as 8 tests. Okay, now how do you get those 8 tests? So, for example, just go Control E. Just put Control E. You will come to this one. Okay, just press Control E. You will come to your edit last dialog box. Okay. Now just go to IMR option. If you're not able to locate it, go to the same process. Stat control chart. Individual chart for individuals. IMR. Okay. Select chocolate weight and go to IMR option. And here the 4th option you can see here. The 4th option is test. Okay. Click on this test. I repeat again. Once you reach here, click on the IMR option. And in the IMR option, there is something called test. Just click on test. Now here you will find out that there is a drop-down menu. The drop-down says, perform all tests for the special causes, perform selected tests for the special causes, and perform no test. Okay. So right now, by default, it was only one test selected. Now what we will do? We will select all tests. Okay. Just select all tests over here. Perform all tests for special causes. Once we select this, just type OK. Just type OK and just type OK. Just a second. Somebody got unmuted. Guys, make sure that you are muted all the time. Okay. Super. How many of you got this? Just type yes in the chat box. The same graph. The same graph. Now we have given some special tests. Now, what are these tests? What are these tests, guys? These tests are basically before the process goes beyond the control limit, the software is telling us there is something wrong. Are you understanding? Okay. Like, for example, it's like, beyond, when a person gets a stroke or a heart attack. Okay. That's where the blood pressure or some other parameters have gone beyond the limit. But can we catch the signals beforehand, like the cholesterol level, like the blood pressure, variation? So this is like identifying the symptoms of the special cause variation before it happens. And it gives you the number of tests which gets failed. For example, you can see here 6, 6, 6. Everywhere you can see here 6. Whenever there is 6 number given, that means 6 number test has failed. Whenever it is 5, it is 5 number test has failed. 4 or 2. Okay. So there are various numbers. So now let's understand what are these tests all about. Okay. So what I'm doing is I'm just going back to IMR chart and going back to the test. And let me just read this test out for you. Okay. So these are the tests. There are 8 different types of tests. Okay. So what we'll do, we'll go one by one and find out what are the significance of this test. Are you clear? Just type yes in the chat box. Clear hai ye? This is before we get the out of control process. We are getting some signals which we cannot see with our naked eyes. Here. Okay. Now, what are these tests? Let me just share with you a document. And this document I'm going to share with you as well. Fantastic. Okay, look at this. The very first and the very basic test is nothing but this one. Okay. Even 1 point out of n standard deviation. Now, n most of the times are considered as 3. Okay. 1 point beyond 3 standard deviation from the center line. So that's where this point comes into picture. So wherever beyond 3 standard deviation, nothing but UCL and LCL. Okay. If your process is going beyond UCL and LCL, that's where your first test has failed. That's where you have seen earlier, whenever the points are going beyond control limit, the number 1 was appearing over there. Yes, are you clear? So the first test is any point going beyond 3 standard deviation is the first test failed. Clear? First test clear hai? That's why it is called first. First point was mentioned over there. Clear? That is called a first test failed. So coming back to this, you can observe our process here. You can see here. See, whenever there is one, okay, one which is failing, you can see here 1, 1, 1, 1. That is called first test failed. Okay. Now let me just share with you what is the second test. Look at it. Second test is k point in a row. Now, what is k? Look at this. This k number is by default will appear in the software. And I would highly recommend not to change these values. These are after a lot of permutation combinations. Software, the statisticians have finalized this value. So I would highly recommend not to change anything in that. Okay. Now, see, it's not like you can't change. You can set up the different values, but ideally you should not change them. Okay, ideally, that is not recommended. Now, the second point is k points in a row in the same side of the center line, which is 9. What does it mean? That means, understand this. Understand this. So what is this second test is saying? 9 points in a row on the one side of the center line. So this is the center line. Okay. If you have 9 points in a row, 1, 2, 3, 4, 5, 6, 7, 8, 9, on only one side of the center line, what does it indicate? What does it indicate? On one side of the center line, all the 9 consecutive points are there. What does it indicate? Type in the chat box, guys. ये क्या हमको दिखाता है? Think about it and then give me the answer. Think about it. What does it indicate? Yes. Yeah, process is stable. See, process right now is stable, but 9 consecutive points are on the one side of the line, one side of the center line. What does it indicate? No. See, try to understand. Try to understand this. This is the center line. Center line is X bar, yes or no? No, center line is X bar, yes or no? Just type yes or no. What is center line? The mean. Correct? Center line is mean, yes? Now, consecutive 9 points are going on one side of X bar is an indication that the process is shifting on one side. Are you clear? Process is shifting on one side. Are you understanding this? Just type yes in the chat box. Are you getting my point? So it is shifting on one side and you will not be able to observe it with your naked eyes. That's why the process is actually, you can see here in the MR chart, you will observe lot of data points are failing because of the 2 number process failed. Can you see here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Are you observing here? Just type yes in the chat box. This circle, all the points are second test failed because 9 consecutive points are coming on one side of the center line. Okay, this is also a danger mark. Okay. Now, third test. K points in a row, all increasing and decreasing. Try to understand. 6, K meaning 6. That means 6 points in a row, all increasing and decreasing. What does it mean? It means like this. If it is increasing, it is like 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 6. So 6 points in a row are increasing or 6 points in a row are decreasing like this. What does it indicate? Type in the chat box. 6 points in a row are increasing trend and 6 points in a row are decreasing trend. What does it indicate? Type in the chat box. What does it indicate? Guys, are you understanding what I'm talking about? Yes, exactly. The process is shifting. The process is slowly going out of the control. Correct. So before it goes out of the control, this is a signal given. The process is becoming unstable. Please observe there. That's what process is saying. Okay. Now here, look at this. The next one is the test number 4. 14 points, k is equal to 14. 14 points in a row, alternating up and down. Now, what does it mean? This is very important. Alternating up and down meaning this is like this. Okay. You have one going up, one going down, one going up, one going down, one going up, one going down, up, down, up, down, up, down, up, down. 14 points in a row. If they are going up and down, up and down, up and down, up and down, that is also an indicator that there might be something wrong in the monitoring. It can be a process which is not maybe a you know what you can say, a signal capturing system like encoder, okay, or whatever electronic device which capturing the points, that may not be giving you the right signal. Are you understanding? Some monitoring flaw can be there. So 14 points in a row, if they are going up and down, you will have to check that. Okay. So this is the test number 4. Okay. So this is first, second, third, and fourth. Are you understanding? The next one, k out of k plus 1 points. What does it mean? So k is equal to 2. So 2 out of 2 plus 1 meaning 2 out of 2 plus 1 meaning 2 out of 3. 2 plus 1 meaning 3. So 2 out of 3 points, more than 2 standard deviation from the center line. What does it mean? What does it mean? What is 2 standard deviation, 1 standard deviation? Let me take you to this diagram, which I had drawn for you. Look at this. Look at this diagram, guys. This is 1 standard deviation. This is 2 standard deviation. This is 3 standard. Yes or no? 1 standard, 2 standard deviation, 3 standard deviation. So any process 2 out of 3 points going beyond 2 standard deviation. So it is actually mentioning this area. Beyond 2 standard deviation meaning this area. This is 1 standard deviation, 2 standard deviation. This is 1 standard deviation, this is 2 standard deviation. So the software is basically explaining this area to you. Beyond 2 standard deviation. So before it goes beyond 3, it is giving you the signal. Are you clear? So before it goes beyond 3, when it actually crosses 2, it is giving you the signal. Clear hai? Just type yes in the chat box. Yes, so these are the signals we are getting before the process goes beyond the control limit. Okay. Very nice. Super. Now,
Sir,
going back
where
to
we
the
can
next.
where we can use this technique, because I have never seen this technique in my organization or working profession.
Are you using control charts?
Yes, sir.
Very good. So now onwards, whenever you are plotting the control chart, go in the control chart. Okay, go in the option, whichever X bar R, I chart, IMR chart, X bar S chart, go to the option and activate all the tests. Okay, what it will do is it will give you signals beforehand. So rather than going beyond the control limit, it will give you signal beforehand. Any red dot you will find that needs to be investigated. Clear? So start this practice. That is the reason we are covering this. So do not only depend on the control limit. Control limit it has gone out of the control. Okay. So before it goes out of the control, can we get some signal beforehand? So software has got this capability to give us the signal, and these are called 8 different tests. Yes. So you can activate this test for any control chart from this onwards, this time onwards. Okay. Yeah. अभी से शुरू कर दीजिए. Yeah.
Okay.
All right. Yeah. Yeah. Chalo. The next one is the k out of k plus 1 points. No, this one. K out of k plus 1 points beyond 1 standard deviation. So 4 out of 5 points beyond 1 standard deviation is also called as a point of concern. Okay, so this is test number 1, 2, 3, 4, 5, and test number 6. Okay, do you observe any test numbers? Yes, can you see here? Test number 6 has failed here. Can you see? Test number 6 has failed here. Okay, what is that? 4 out of 5 points more than one standard deviation. So if I plot imaginary dotted lines of the standard deviation here like this, okay, so it would look like this. Okay, so 4 out of 5 consecutive points are going beyond this. Let's say, for example, look at this. 1, 2, 3, 4, 5. So here you can see the 6th point is shown in red. Okay, so any 6 points. So wherever you get the red dots, very simple. Let's make it very simple. Activate all the tests, and wherever there is a red dot, you just have to go a little deeper and understand this. Okay, see, I always tell this. Whenever you make a graph, to understand the graph, just observe that graph for 30 seconds. Observe that graph for 1 minute, 2 minutes. That graph will start speaking with you. You will start understanding the deeper meaning of that graph. You know, your smaller, what you can say, the peaks and the valleys, the trends and the patterns, all these things will be visible if you start focusing on the graph. And if you activate this test, it will be something, which will be helpful for you as well. Here, processes started to shift. Yes, exactly. So that means the process has started shifting in first standard deviation. Okay, it will go to the second standard deviation. So before that, you can capture this. Okay, so we are going, deeper into that. Then the next one is k point in a row within one standard deviation of the center line. So 15, k is 15. So 15 points in a row within one standard deviation. Understand this. So that means 15 points. So if this is the center line and I have 15 points in a row in between one standard deviation only. Okay, 1, 2, 3, 4, 5, 6, 7, 8, like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all these are 15 points within one standard deviation. If I have, that is also a test failed, which is 7 test failed. And the last one is 8 points in a row beyond one standard deviation from the center line. That means beyond one standard deviation, meaning between second and the third standard deviation. Okay. Now, test failed meaning the process is stable, but this test failed meaning there is something special which is happening there. Test failed ka matlab hai, there is something special happening over there. You need to investigate. See, these are statistical signals. You need to investigate what exactly is happening. Okay, it can be instrumental error, it can be recording error, it can be a process which is stuck, software error, whatever it is there is something going wrong. It is not normal, it is abnormal happening. That is what these tests are saying us. Okay, can you please explain K15? K15 is, so 15 rows, for example, look at this. If this is my X bar, this is my 1 standard deviation, 2 standard deviation, and then upper control limit. Okay, again, 1 standard deviation, 2 standard deviation, and lower control limit. Now, what this test is saying us, so this is my lower control. So what this one, okay, the second last test is saying us 15 points in a row within one standard deviation. For example, if you have, let's say, 15 samples, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15, points within one standard deviation. What does it mean? It means process is slowly but surely shifting in one direction. Process is from this center line slowly but surely shifting towards higher. If it is on the lower side, okay, it is shifting toward the lower. So that you need to identify here. So once you follow this, once you see the test number 7, this is called a test number 7. So whenever you get 7 number, you have to check this test and this will be followed. Okay. What is the ideal sample size? Anything beyond 30 data points is the ideal sample size. Okay. For statistics, anything beyond 30 data points, it is ideal. 30, 40, 50, 100, more than 30 is ideal. Less than 30, not recommended. Okay. Now, the last one is 8 data points in a row beyond one standard deviation of the center line. Okay. So beyond one meaning this region. 8 data points, if they are going beyond one standard deviation, this region consecutively, that means the process is shifting. Okay. So these are the 8 different tests. So whenever we are doing the control limits, control charts, please activate all the tests and let it get what you can say highlighted over there. Are you clear? Just type yes in the chat box. Clear hai everybody? Super. So now onwards, we will start making this change. Okay. We will go one step beyond. We will not only do the control chart, we will do the control chart with all the tests activated. Yeah. Very nice. Now just one question. Okay. One question. IMR chart है ना, इसका एक काम करते हैं. Let's do one thing. Beyond the control levels, what control measures can we take? Have to repeat the process or what? Okay, fantastic. Yes. Now, what if the points are going beyond control limits? What needs to be done? What needs to be done? That's the first question. Okay. What if the points are going beyond control limits? What process activities? Now, the first step is investigate. Write this down. First, you need to investigate. Okay. Now, if you have only one data point which is going beyond control limit, etc., you can investigate and remove that data point from the data. Only one data point. It's kind of a special cause variation. You have taken care of that, and it is only one data point. Then you can. But if there are various data points in your data set, that means the process is unstable process. See, even one data point, yes, process is unstable, but it is manageable. You can just investigate and remove the data point, that process becomes stable. Okay. But if you have multiple data points, it is not advisable to remove the data points only. First, investigate, then take some corrective preventive action. Corrective and preventive action. So that investigation, meaning in investigation, you have to do a simple common investigation. Like why, what are the reasons? Okay. You can use cause and effect viva analysis for investigation to find out the root causes. Then you take the solutions, the action in corrective and preventive. Okay. And then you do the same control chart once again. Okay. It should be within the control limits. Then only you can go for the process capability analysis. If the process is unstable, do not do the process capability analysis. It will go haywire. Are you understanding? It is not advisable to do the process capability analysis when the control limits, the process is out of control. Yes, so investigate, take corrective preventive measure, bring the process within the control, then only you can do the process capability analysis. Clear, everybody? Just type yes in the chat box. Just type yes in the chat box. Everybody clear? Yes? Super clear? Very good. Very good. Now, let me just bring one very important factor into consideration here. Just go back to the data. Okay. Now, what we'll do, we will do X bar S chart. Okay. We will do X bar S chart. Go to stat, control chart, variable control chart for subgroup, X bar S. Now, when do we use X bar S chart? When we have subgroup sample. Subgroup meaning in a sample, when we take the sample, we are not taking one sample, we are taking group of samples. That is called subgroup sampling. Subgroup sampling. Okay, here you can see here, there are, in the first sample, they have taken 10 chocolates. Okay. Second sample also, they have taken 10 chocolates. So they've taken a subgroup. Okay. Now we will do X bar S chart. Now X bar S is, X bar remain exactly same. How X bar S chart will be created? X bar will be the average of this. This is called X bar. So it will be calculating the average of this. And S meaning the standard deviation. Okay. So there will be two charts will be actually plotted. First chart will be X bar chart, the average chart. And for the same data set, the standard deviation, sigma, will be calculated and this will be plotted. Okay. So in the first graph, it will be X bar. And the second graph, it will be standard deviation. Okay. Now let's plot it. We'll understand it. This is very important message I want to convey. So let's understand this. X bar, go to stat, control chart, variable chart for subgroups, S bar, X bar S. Select this, X bar S chart. Okay. Now here, you have to select chocolate weight, and the subgroup size, you have to select sample. Clear, everybody? Chocolate weight and sample. Now we will activate the test. We'll activate all the tests. Go to X bar S option and activate all the tests. Wow. So this is very, very stable process. Now this is, look at this. Right now, this is the average of the first group of 10 chocolates. And this is the standard deviation of the first 10 chocolates. Okay. Which we call it as S basically. S is for the sample and sigma is for the population. Okay. So this is for S. Actually, it is S1, S2, S3 for the third sample, fourth sample, etc. So second sample average, the third sample average, the fourth sample average, etc. Clear hai? No, software will calculate. There is a formula similar to X bar plus minus 3 standard deviation. Similarly, software will calculate this automatically for us. So we need not to set this up. Software will calculate it automatically. You just have to feed the data. That's it. Clear? Everybody got this? यहाँ तक समझ में आया? Just type yes in the chat box. Everybody? Clear है? So this is basically X bar is indicating the mean, which is the central tendency of the data. Where is the average lying? Okay. And this is actually standard deviation, which is denoting the dispersion of the data. So this is called mean standard deviation chart. One is checking the central tendency, second is taking the dispersion. Clear hai? Our test on 12 samples? Yes. Not a single test has failed here. We have activated the test, but not a single test has failed here. The step is go to stat, control chart for variable, the subgroups, control chart for subgroups, and you select X bar S chart. Clear? Yahan tak everybody clear? Just type yes in the chat box. So we have activated this, but not a single test has failed now. Now, understand this, huh? Understand this. If this data point, if any data point goes beyond, if any data point goes beyond We have to investigate and take action. Correct? Yes or no? Any data point goes beyond, we have to investigate and take action. Yes or no? Everybody? Clear hand? Because the process is shifting. Correct? Now, any data point goes beyond this lower control limit, also we have to investigate. Not only upper control limit, but below control, lower control limit also the process goes, we have to investigate. Are you clear? Yes? So both ways, above and below the control limits, you have to investigate and take action and bring the process in the center. So we have to bring the process in the center. That's our objective. How to set LCL and UCL? See, do you remember I mentioned about X bar plus 3 standard deviation, X bar minus 3 standard deviation. So software calculates the standard deviation, calculates the X bar and set up upper control limit and lower control limit. Clear, Viddu Kumarji? Just type yes in the chat box. So you just have to feed the data, software will calculate automatically. Yes. Clear, hai? Now, coming back to this. Now, same goes with standard deviation. If it goes above control limit, here, if any data point goes like this, you have to investigate and take action. I for investigate and take action. But listen to me very carefully. Any data point goes below control limit of this, you just investigate, but do not take any action. Just try to understand this, huh? Try to understand it. This is the first graph. The first graph. Okay, huh? This graph is basically the average. How the average is shifting. Okay, so average is shifting. That is being plotted here. The average is shifting. That is being plotted here. Okay, that is being plotted here. So first average is here, then the second average is here, third average is here, fourth average is here, fifth average is here, sixth average is here. Are you understanding? Then here in the second plot, what are we plotting? The standard deviation we're plotting. Are you understanding? So whatever is the standard deviation. So in the first case, this is the standard deviation. It is 1 point, very close to 1.5. Second is also very close to 1.5. Okay, this one is 2.0. Can you see here? This one is 2.0. Let's say if it goes beyond 2.7, let's say 3. If the standard deviation is 3, that means there is more variation, yes or no? If it goes beyond 2.7, that means the more variation, standard deviation indicates variation, yes or no? Are you understanding? Everybody, try to focus here. Standard deviation indicates the variation. If this is my process, this is my mean, X bar, which is plotted by this graph. And this one, this spread, is basically plotted by standard deviation sigma. Yes or no? Now, more the standard deviation, more will be the, more will be the spread, more will be the standard deviation, right? Now, if it goes beyond 3, you have to investigate and take action and bring it within control limit. Are you understanding? Now, coming back to the lower control limit. But as you go below, okay, as you go below, let's say if the standard deviation goes below 0.5, what does it indicate? It indicates the process is becoming very, very close. How many of you got this? Let's say the process, if this row going down, what does it indicate? The standard deviation is reducing. Even if it goes below control limits, you do not have to take any action because it's a good thing for us. How many of you got this? Just type yes in the chat box. The graph below is the standard deviation graph. And if the standard deviation graph is going down, If it goes below control limit, don't take any action. It is good thing. ये अच्छा है, यही हमें चाहिए. सर ने बताया कंट्रोल लिमिट के बाहर गए तो प्रोसेस के लिए हमें चेंज करना है. नो. If it goes be upper see, understand this. For this graph, for the second graph, focus here guys, focus here. Focus करेंगे तो समझ में आएगा. Standard deviation is this. जितना भी स्प्रेड है आपका, जितना आपका स्प्रेड है, that is the standard deviation. If the standard deviation is going up, let's say if your process is going like this, that means your standard deviation is increasing. If your process is going like this, that means your standard deviation is reducing. When your standard deviation is reducing, even though it goes below control limit, do not take any action. It's a good thing to have. Rohit ji, got it now? Now you will understand this. So see, if the standard deviation is increasing, you take action. If standard deviation is decreasing, don't take action. Got it? Yes. So now onwards, these are the two things we have followed. Do not just make the control charts, understand the depth of it. Okay. Activate the test and upper control, lower control for the X bar, you have to take the action. For the standard deviation, for the range, for the above upper control, you have to take the action, but below lower control, you don't have to take the action because we are actually looking to reduce the variation. Okay. Because, what you can say, if 9 goes, test will fail. Yeah, let it fail. For the specification, for this standard deviation graph, no? See, this is my mean graph. This is my mean chart. And this is my standard deviation chart. Okay. So any data which is going down here below, 9 dots, 10 dots, 15 dots, it's good for us. It is going down, meaning the standard deviation reducing subsequently. So let it fail. You should not take any action on that. Clear hai? If it is going above control limit, then you have to take action. So understand this. So this is the action zone. For standard deviation chart, this is the action zone. If it is going below this, it is a good thing. Clear? Very good, very good. Super. Now, are you clear with this? Just type yes in the chat box, guys. समझ में आया? Test समझ में आई? 8 tests. Now start utilizing these types of tests and start utilizing this. Okay. Yeah, Guddu ji, what you have not understood? Can you just unmute and ask me the question quickly? What you have not understood? Yeah, just unmute yourself and ask the question. In this, you have not what you have not understood. There would be unmute option available. I hope it is activated.
Hello, sir.
Yeah.
Actually, I'm asking if you see bell-shape curve, means there are both condition of deviation, mean one side and other side also. So if the process will be going downside, means beyond lower limit, then why should not take the action?
No. If your process is going in lower side, it will show over here in this graph. Okay. In this X bar graph. But this graph is entirely different. This graph is about a standard deviation of the process. Understand this?
Right, sir.
Okay. So whenever we are taking the subgroup and that subgroup, let's say imagine the first 10 samples, the the standard deviation is let's say 1.5. Imagine this one only. Where is that? Yeah. The first subgroup. Imagine we have taken a batch of 10 samples and the standard deviation is 1.5. Now imagine that standard deviation is going down. It has gone to 0.2. Now what does it indicate? It indicates the variability has reduced. No, from 1.5 it has reduced to 0.2. That means the variation has reduced drastically, and which is what we are expecting. So see, if the process is going in this case, that's what I'm saying. In this case, you are right. If it is going below this, you have to take action. But if the process is going below this, no action. actually this is the ideal situation. If it becomes 0, that is what we are expecting, because variation
Okay.
is killing our profit. Are you understanding? Yes.
Yes, sir. Yes, sir. Means the deviation will be 0, then the process
Correct.
automatically will be ideal
Exactly.
condition, and so that's why we have
Correct.
to not
Correct.
take any action.
Correct.
Okay,
Correct.
okay.
Yeah.
Thank
So
you,
you have
sir.
to. Yeah.
Okay.
So remember these 4 areas: upper control of this X bar chart, take action; lower control, take action; upper control of S, the standard deviation, take action; lower control, no action. Remember this thing.
Right, sir.
Okay.
Yes,
Clear
sir.
now?
Okay, sir.
Well,
Thank you.
yeah. Super. Now, one thing. Yes. So just one quick update about this. Take the same factor and let me just plot a graphical summary of this. Okay. Now, everybody knows this. Everybody knows this, right? 95% confidence interval of mean. So this is a descriptive statistics and this is inferential statistics. What does it mean? It means with 95% confidence, see, understand this. For this data, the mean is 42.106. And with 95% confidence, we can say that the mean of the population, because this is a sample of 120 data points. There are 120 data points, just a small sample. From this sample, we are predicting about the long, big population. So we are with 95% confidence, we are saying that the average, the mean of the population will lie between 41.808 to 42.403. Okay. So what is it? Why do we use this 95% confidence interval? That is the question a lot of people ask. And what is the formula for that? So let me give you the formula to calculate this, and let me give you a simple example, a practical example. Okay. For one of the pharmaceutical company, let's take this example. For some one of this pharmaceutical company which make, let's say, 500 mg tablet. Imagine, okay, a pharma company is making this, and their specification limits are plus and minus 5 mg. So what does it mean? The lower specification limit for this tablet is 495 mg. The target is 500, and the upper specification limit is 505 mg. Clear, everybody? Super clear. So just I'll give you a practical example where this 95% confidence interval is used. Where a lot of people ask this question: why are we calculating this, etc. Okay. Now, anybody from pharma here? Just type me in the chat box. Pharma se koi hai yahan pe? Amol ji is from pharma. Who else? Type quickly. Pharma, Nutra, UB, API, जो भी है, any relative field. Okay. So let me give you a quick. So what they do is, one of the group of engineers, they took 30 tablets. So just for testing, okay. So n is equal to 30, and they found that the average X bar of those tablets, the mg basically, found to be 498. Okay, found to be 498. And the standard deviation they found, which is sigma, standard deviation sigma, they found to be 5 mg. Okay, now let's calculate the 95% confidence interval for mean. So 95% confidence interval CI for mean, the formula is, I'll give you the formula in manual. Mean plus and minus in bracket Z into standard deviation divided by square root of n. Okay, formula close. Now Z value, the Z ka value for the 95% CI is constant at 95% confidence interval. Z is equal to 1.96. Okay. So can you just calculate this quickly? Pull out your calcs and give me the answer. So the mean here is 498 plus minus Z is equal to 1.96 into standard deviation is 5 divided by square root of n, which is square root of 30. Bracket close. Can you just calculate this and give me the answer? Plus and minus both, okay? Chalo, I've given you the formula, I have given you the practical case, and let's understand this. So they have taken the 30 samples, they have taken the tablets, they have checked the the mg of the tablet, and they found the average found to be 498 mg. Standard deviation found to be 5. So they calculate 95% confidence interval for me because they've taken 30 tablet sample and they want to predict about the entire batch. Entire batch is the population and 30 tablets is the sample. So what is the answer here? Type in the chat box quickly. Z is 1.96. It's a constant. At 95% confidence interval, Z becomes 1.96. Okay? You can take 1.96 as a constant. Okay, so what is the 95% confidence interval here is 496.21 and 499.79. Everybody got this? $496.21 and 499.79. Everybody got this? Just type yes in the chat box. Super. So with 95% confidence, if they want to check the batch, they predict about the batch, the mean of that batch, the mg mean of that batch will lie between 496.21 and 499.79. Now, if I plot it over here, let's say if I plot it, 500 mg is my target. My upper specification is 505. My lower specification is 595. Now, if I plot this, it will come like this, something like this, right? 498 is the average. And here, this is 499.79. And this is 496.21. Okay, so the process will look like this. How many of you got this? Just type yes in the chat box. And this is 498, which is the average. Have you got this? Just type yes in the chat box. How many of you got this? Focus here. What I've just drawn it for you. No, it is not skewed. It is normal distributed, but it has shifted on one side. What is the conclusion? The first question, let me ask you the first question. Will you accept the batch? Type in the chat box. Will you accept the batch? Will you accept this batch? Focus here and tell me. Will you accept? Yes, I will accept the batch because with 95% confidence, you can see here, it is between 496 and 499. Okay, so at least it is within the specification limit. So I will accept the batch, but it is clearly indicating that the process is shifting on the lower side. So I have to take immediate action to bring the process to the center. Yes or no? I will accept the batch because the batch is on the boundary line acceptable. Correct? Even a one small shift can bring that entire batch outside of the specification limit. Are you clear? So as of now, the process is on the boundary line, but it may not remain on the boundary line. It may shift. Okay. So there, 95% confidence interval can give us some indication that in the future where this process will lie. Okay, as far as the population is concerned. Are you clear? So when we are taking the 30 tablets as a sample to predict about the entire batch, we can take help of 95% confidence interval. Are you clear with this? Just type yes in chat box. And just remember this formula, take down this formula with you. So everywhere you will find down the find this formula for standard deviation, find this formula for median. Okay, and the same funda will be utilized. Okay, so this is how practically 95% confidence interval is used. Okay, super clear with this? Very nice, very nice. Chalo, let me open this forum for the question and answer. Okay, so any question you have, you can just ask this.